All right, hello everyone. I'm not here today, but I'm happy that you are. And today's a great day to review the main concepts we've learned in class the last period. So if you were absent, there's copies of filled out notes under the calculator box in the front of the classroom. Please grab one and get ready to dive right into our new unit, waves. You definitely want to have those notes. They're for sure going to help you on the assignments from today. So watch this video as many times as you need to. Feel free to pause so you can test to see if you can calculate the things at your own pace. I'll probably say pause the video now if you'd like, and good luck. Yeah, here we go. So we've been studying waves. That's the last thing we took notes on. And when we think about it, like, when does this stuff actually matter? And the answer is all the time. Basically, one big place where this matters is boats on the water. Yeah, look at those boats bobbing up and down. So when energy travels through water, it can cause some crazy stuff to happen and can make it very difficult to live in those conditions, particularly when docking and parking those boats. So today we're going to do a little assignment called Don't Rock the Boat. So for this next task, you'll be trying to figure out how the properties of waves coming into a location with two docked boats. This is to practice vocabulary and some math skills. Yay! Use your notes and your groups to help answer the questions that you have been assigned. So don't rock the boat. Look at that dinosaur driving a boat. Gosh, that's cool. So don't rock the boat sample problems. These are your first two problems on your worksheet that you got today. So do your best to follow along as we go. Half your points from this first assignment come from this front page. So this is a free 50% as long as you can follow along as we go. So the way the scenarios are set up is it's always going to talk about two boats. And the first part is figuring out where does the second boat go. It says two boats are anchored in the harbor, separated by a horizontal distance of 16 meters. Now keep in mind, horizontal means sideways, right? Left and right, whereas vertical distance would be up and down. So horizontal is saying that we have 16 meters between these boats. The boats bob up and down as waves enter the harbor. When one boat is at its highest point, the other boat is at its lowest point. And there are no wave crests between them. Where should the second boat be? Should it be at location A, location B, location C, location D, E, F, or G? Pause right now if you want to test yourself and see where should this boat be. If you picked position A, you're correct. Yeah, so first of all, it's saying that when it's at its highest point, the other one is at its lowest point. So automatically we know it can't be at B, D, or S. It's got to be one of these bottom letters. And then this clue where it says there's no wave crest between them, I know it has to be A, because if it was C, there would be this wave crest for B in between our two boats. So A is our only option for this particular problem. Now, as we go forward through these other problems, you have a piece of paper. I'm going to show you how to hild up. So this is where you highlight, underline, or circle numbers in word problems, identify your variables, label your drawing if you need to, and double check your answers with another person or with your calculator. Those are the best things that you can do. So we'll go through these first problems one at a time, and I'll show you how to do this whole process to hopefully minimize any errors and maximize your success. So the rest of this problem, right, we've identified where our boat is. Hopefully you drew where the boat is. If you haven't, draw a little boat in that location where it's supposed to be on your paper now. So we have the same scenario. It says again, two boats are anchored in the harbor, separated by a horizontal distance of 16 meters. That's great, wonderful. The boats bob up and down as the waves enter the harbor. That's what boats do. Each boat makes exactly 3 complete up and down cycles every 12 seconds. The vertical distance between the boat's highest and lowest position is 3.2 meters. Hopefully we're going to use at least 2 significant figures. Now you'll notice that all of our equations are at the top of the screen here. We've got period is time divided by cycles, speed is wavelength divided by period, and frequency is cycles divided by time. Now speed, this is a new equation up here. You also could do speed is wavelength times frequency. I changed it to this one just to make it easier as you're going through these problems. So we're going to be answering what is wavelength, what is period, what is speed, what is frequency, and what is amplitude. Now, one thing you want to do when we held up is you want to underline the important terms. So here you can see I underlined horizontal distance of 16 meters. I know I'm going to need that piece of information. And while I'm at it, I'm going to go and underline all the other words and numbers that are going to be important. So the next thing I'm going to underline is this 3 complete, because it's talking about 3 complete up and down cycles. I know I'm going to need cycles. I'll need them for my equations. I'll also underline 12 seconds because I'm going to need my time period. And then the last thing I'm going to underline is the distance between the highest and lowest position, which is 3.2 meters. So anytime you get a word problem like this, especially as we get into heavier physics problems, you want to underline the important things and numbers. And honestly, the numbers are the most important thing. So if we're trying to figure out our wavelength, right, we're trying to figure out how far is it from one crest to another crest. Now, what we know so far is 16 meters is between our two boats, right? If you don't have that on your paper, go ahead and write that down now. We know this distance is 16 meters. But the problem is I want to know what a full wavelength is. So what I have to do is I have to take that 16 meters and I got to multiply it by 2. Because as of right now, this is just half a wave. So I got to multiply it by 2 to get the full distance to that next wave crest. And the answer should be, go ahead and type it in your calculator. The answer is 32. 32 meters is correct. Congratulations. The next part is we're going to be calculating period. Now, if we look at our equation at the top of the screen, period is time divided by cycles. So time divided by cycles. So I'm going to look in my equation. I'm going to find where the time is. And it says right here, we got 12 seconds is our time. I know it's time because it's measured in seconds. Now, the other thing we're going to try to measure is how many cycles do we have? And that's this other underlined thing we have here. 3 complete up and down cycles every 12 seconds. So to figure out period, I'm going to take my 12 seconds and I'm going to divide it by 3 cycles, right? Time divided by cycles. Time, cycles, plug that into your calculator and you should get 4 seconds. So your unit for period will always be in seconds. It's always going to be a unit of time. So keep that in mind. So 4 seconds is our answer there. Our next question that we're going to answer is what is speed? Now, again, in this case, you could do wavelength times frequency. That would absolutely work, but we have not calculated our frequency yet. So you can either wait until after you calculate frequency, or you can use this equation where it says wavelength divided by period. It means the same thing. And if we decide to go with wavelength divided by period, I do have those two numbers. I've got 32 meters for my wavelength and 4 seconds for the period. So what I'm going to do is do my wavelength, 32 meters, and divide it by 4 seconds. And if I plug that in my calculator, I get 8 meters per second. And the reason why we have meters per second is because speed will always be a distance divided by time. And that's what we have, meters divided by seconds. That's how we get that unit. Next up, we're going to do frequency. Frequency is cycles divided by time. So I already know how many cycles I have. I found it's 3 complete up and down cycles, which means 3 goes on top. And time is 12 seconds. So that is my denominator. So I take 3 cycles and I divide it by 12 seconds. And I get an answer of 0.25 hertz. Don't forget our unit for frequency is hertz. So 0.25 hertz should be my answer for frequency. Now our last question that we're going to do here is going to be about amplitude. And this is where I need to figure out my vertical distance, right? Our wavelength goes sideways, but our amplitude is going up and down. Now for this equation, or for this problem, I should say, the vertical distance between the boats, highest and lowest position is 3.2 meters. So I'm going to add that on my drawing. It's going to make it easier for me to visualize what I'm actually looking at. So 3.2 meters is the distance from the tallest point of my boats and the shortest point of my boats. But keep in mind, that distance is not our amplitude. I need half of this distance, right? We got to go from a resting position. So what I'm going to do is I'm going to divide this number in 2 to get the actual amplitude. So I take 3.2 and I cut it in half. So 3.2 divided by 2 gives me an answer of 1.6 meters. And that is how you solve these problems. So we found all of our answers, we've labeled our drawing, we underlined important words, and I also showed my work. So as you're going through all these problems, there's that giant blank space next to all of your numbers and all of your lines because I'm expecting you to show me your work. Show me how you're getting these answers. I know some of you can do this math in your head. Sometimes you can, sometimes you can't. Show me you know the method of how to find it. You don't need to tell me it's wavelength divided by period, but I am going to expect to see what numbers you're dividing to get your answers. Let's do one more practice problem.